Hi everyone, in this video we are going to learn about what is stack and its operations. First thing what we have to know is what is the use of this stack. Very simple, stack is used, it is used to store data. It is used to store the data. Data like values 10, 20, 30 and also characters like A, B, C and so on. So basically stack is a one kind of a structure which is used to store the data. Not only storing the data, you should also learn how to get the data or retrieve the data. So for that we have two important operations. First one is push operation for storing the data and pop operation for getting or deleting the data or retrieving the data. Let's see some real-time examples of stack. The first one is stack of books. Here we are putting a book on the other book. And second one is a stack of plates. And third one is a stack of DVDs. And what makes this stack very special is, for example, if you want to take this book, you cannot take it directly. Before that, you have to remove all these four books from the stack. Then only you can take this book. Similarly, if you want to take any CD in the middle of this stack, you cannot take this CD. Before that, you have to remove all these CDs one by one. Then only you can able to remove this CD from the stack. So this makes or this idea makes the stack very special. And this property is used to solve so many problems. And these are all the stuff that are related to the stack. In examination you have to write all these points one by one. First one is the stack definition, stack operations. We have mainly push and pop operations, and what is the top of the stack, and what is the meaning of stack overflow, stack underflow, and what are the applications of stack. And finally we will see one example also. This example is very important, so watch the video till the end. Okay, so firstly we will see the stack definition. Stack is a linear data structure. Stack is a linear data structure. What is the meaning of data structure? A structure which is used to store the data, and linearity is a property. So stack is a linear data structure in which addition of elements and deletion of elements. See here, addition of elements and deletion of elements to the stack are done at only one end called the top. For example, I am going to consider this one as a stack, and if I want to add any elements, so this end I am going to add the elements. For example, if you want to add 10, so 10 will come here at the bottom, right? It is the first book according to our examples. And if I want to add one more value, so on the top of the 10 I am going to have this 20. And if you want delete, so from this end only you are going to delete. So the addition of elements and deletion of elements are done at this top end only. Okay, and the second point which is most important is stack is also called as LIFO data structure. What is the meaning of LIFO? Last in, first out. Okay, so LI, first out, LIFO. What is the meaning of this? Suppose if you take here, you have already 10, 20 and assume 30 is also there, and tell me what is the element that was recently added, that is 30. First we have added 10, next we have added 20, and recently we have added 30. So this is the last element. If you want to delete the element from the stack, we have to delete 30 only, right? So 30 came last and it should come first. That is the meaning of last in, first out. So stack is called as last in, first out data structure. So you have to write all these points in the examination in your own words. And next, stack operations. So you have totally six important stack operations. Among them, push and pop are most important. What is the push operation? Very simple. Adding an element. Adding an element to the stack is called as push operation. What is the meaning of that? Suppose if we have already in the stack 10 and 20, I want to add one more element. So you have to perform the push operation. Suppose if you want to push an 30 or if you want to add 30, so you have to push the 30. So then this 30 will come to the stack and it will be added to the stack. And now 30 is the topmost element. And next one is a pop operation. Very simple. Deleting an element. Deleting an element from the stack. That is called as a pop operation. For example, if we have three elements in the stack, if you want to delete, which element will be deleted? Yes, 30 will be deleted because 30 is on the top. Topmost element will be deleted. And next one is a display. Display is nothing but printing all the elements. Printing all the elements in the stack. Now if you see this example, there are three elements and we will try to display all these three elements on the screen like the 10, 20 and 30 are the elements present in the stack. And next one is peak operation. Finding the topmost element in the stack is called as peak operation. For example, see here among this 10, 20 and 30, 30 is the topmost element. 30 is the topmost element. The difference between this pop and peak is the pop will remove this 30 from the stack, but whenever you use a peak, it will not remove, but it will tell you what is the topmost element in the stack. That is the difference between the pop and peak. And next one is empty. So this function or this operation is used to know whether the stack is empty or not. Used to know whether the stack is empty or not. And is full, it is quite opposite to the is empty. So is full means it is used to know whether the stack is full, right? So you can write all these things in the examination, no problem. And next one is what is the top of the stack. So you have to know what is the top of the stack. The first point is basically it is a variable. It is a variable, right? And it points to the index of the topmost element. Remember, it is pointing to the index. So most of you will write it points to the topmost element. That is not right. It points to the index of the topmost element. For example, you take a stack like this. You have the values 10, 20 and 30 already in the stack. And here I am implementing the stack by using the array. Okay, two ways are there. First one is by using array. Second way is by using the linked list. So in this example, I am showing the implementation of stack by using the array. So whenever I say array, it is going to have the indexes 0, 1, 2, 3 and so on, right? Here the topmost element is 30 and it is stored at index 2 and this 2 will be stored in a variable called top, right? So top stores the index of the topmost element 30 like that. And the next definition is a stack overflow. The first thing what we have to know is basically it is a error situation. It is a error condition or error situation in the stack. Okay. Now we have to know what is the error. Take this example. Here I have a stack of size 5 and already 5 elements are there in the stack 10, 20, 30, 40 and 50, right? Now if I want to add 60 also, if I want to add this 60 to the stack, is it possible? Obviously not possible. What is the reason? There is no space in the stack. There is no space in the stack. Okay, so in this case, if you try to push this 60, it leads to a error situation. That error situation is called stack overflow. Stack overflow. Let's see the definition. So whatever we have discussed here, the same thing I have written in the words. If you try to push, or if you try to add or push an element to the stack, and if the stack is already full like this, the stack is already full, then you cannot add, right? So then this error situation is called stack overflow. Stack overflow. Hope you understood this. And next one is stack underflow. I told you stack underflow is quite opposite to the overflow. So it is also a error situation. Okay, it is a error situation. It is a error situation. And before seeing the definition, let's see what is the meaning of stack underflow. Suppose you take this stack and assume that there are no elements in the stack. There are no elements in the stack. If there are no elements in the stack, you cannot delete the item, right? And if you try to do it, then it leads to a error situation. So that situation is called as a stack underflow, right? So try to keep that discussion in the form of a sentence. See the definition. If the stack is empty like this, there are no elements in the stack, and if you try to delete an element from it, which is actually not possible, then that leads to a error situation called stack underflow. So in examination, you can write this definition in your own words. Okay. And see the next one, applications of stack. What is the meaning of applications of stack? It is nothing but the places where we are going to use this stack in order to solve some problems, right? So all these are some problems. In order to solve these problems, we are going to use the stack there. We are going to use the stack. So that's why, so all these are called as applications of the stack. First one is reversing a string. That means if the input string is like, Ramu, you have to print the reverse of this, okay, something like UMAR. So in this process I can use the stack. So this is called as application of a stack. Like that we have some other applications like check validity of a mathematical expression, whether it is a valid expression or not. You can find it by using the help of the stack. Next, convert infix expression to the postfix expression. It is the most important one. And convert decimal numbers in various number systems, like converting a decimal number to the octal number, or decimal number to a hexadecimal number. In all these conversions, we can use the stack. And last one is evaluate a postfix expression. This is also very, very important from the examination point of view. Now we have discussed all the stuff that was related to the stack. Now we will see one example, okay, how we can add the elements, how we can delete the elements from the stack. All these things we understand by taking an example. So here I am going to take the size of the stack as 3, okay. So int stack of 3. So here I am implementing the stack by using the arrays. Generally, we generally represent the stack horizontally like this, right? But for this stack, for my convenience, I am representing the stack vertically. This is only for the convenience, okay? Only for better understanding of the concept. And array indexing starts from 0, 1, 2. So this is a initial status, right? So I can take it as initially the stack is like this. And remember, when there are no elements in the stack, the top value will be -1. The top value will be -1. So I write this initially here, okay. So a initially And in the next step, I want to add one element. Okay, so you have to use the push operation. So I want to push the value 10. See here, whenever you want to perform a push operation, you have to perform all these four steps one by one. First one is check for stack overflow. See here, what is the meaning of stack overflow? Stack is full, right? So in this case, our stack is empty. So you have to come to the second step only if the stack is not full. Remember that. If the stack is full, you have to stop at the first step only. Because our stack is not full, come to the second step, increment the top. Now what is the present value of top? -1. So you add 1 to it. -1 plus 1 becomes 0. So top value becomes 0. So indicate that here. So top value becomes 0 now. Next step is read the element. So whatever the element or value you want to add to the stack, you read that element from the keyboard while writing the program. Okay. Now I have read 10 from the keyboard. And fourth step, add the element to the stack. So add this 10 to the stack. So for every push operation, you have to do all these four steps. Remember. And okay, let's push one more element. Push of 20. The first thing what we have to do is check for the stack overflow or stack full. Now tell me, is your stack full now? No, there are two spaces, two empty spaces. So stack is not full. Then come to the second point, increment the top. What is the value of top now? Is 0. You add 1 to it, it becomes 1. So your array will look like this, or your stack will look like this. So this is 0, this is 1, this is 2, and increment this top. Top becomes 1. Already 10 is there. Now read the element. Yes, I have read 20 from the keyboard and add the element. Fourth point, add the element to the stack. So add 20 to the stack. So you have to do this process for every push operation. Next one is D. I want to push one more element, that is 30. So take the stack again. Yeah, already 10 and 20 are there. The first thing is you have to check whether the stack is empty or not. I mean, space is there or not. Yes, we have space here. Increment the top. Previously top value is 1. Now make it as 2. Right? And read the element from the keyboard, that is 30, and add the element to the stack. Now the stack is full, right? And if I try to insert one more element, that is push of 40, what is going to happen? See here, in the first step, check for stack overflow. The stack is already full, right? So whenever the stack is full, you cannot add one more element. So it leads to a error situation. I told you already. That situation is called as a stack overflow. So stack overflow, right? So you cannot add one more element. Now I can delete, right? So I want to perform the pop operation. So as we have four steps for the push operation, we also have steps for the pop operation. I am deleting all these things here. Now I will write the steps for the pop operation. Yes, see here you have three steps here. Check for the stack underflow or stack empty. The first thing what you have to do is check for the stack empty, right? If the stack is not empty, then only you have to come to the second step. Okay, if the stack is not empty, then only you have to come to the second step. Otherwise, if the stack is empty, you have to stop at this point only, right? And second one is remove the element, and third one is decrement the top. Let's do it one by one. So at present you have three elements in the stack. So do the first step. Yes, obviously stack is not empty. There are three elements. So come to the second step. Remove the element. That means if you have 30 on the top, right? So you remove this 30 from the stack. Yes, so 30 will be removed from here. And third step is decrement the top. So top value is presently 2. When you decrement it, it becomes 1. So this will become the top, right? And perform one more pop operation. One more pop operation. The first one is yes, check for stack empty. Yes, stack is not empty. So what happens? Delete the next element. That is delete the topmost element. That is 20 will be deleted, and you are left with only 10, whose index is 0, and decrement the top. So top value is 1. Decrement 1 from it, so it becomes 0. Right? Now this is the current situation of the stack. There is only one element, and you try to perform one more pop operation. So F is a pop operation. So what is going to happen? So we have only one element in the stack, and that one will be deleted. That one will be deleted, and remove the element, and last one is decrement the top. So the top value becomes -1. Top value becomes again -1. And now if you again perform the pop operation, now you have a problem. The problem is there are no elements in the stack. So at the first step, you will get the problem. So because the stack is empty, it leads to a error situation called stack underflow. The stack underflow will be printed, right? So in examination, you have to draw all these figures one by one, then only you will get full marks. In this video, I have explained the concept of the stack. In the next video, I will discuss the program for this, right?